We're going to move our area questions into a little bit harder place now. Because what we want to do is look at the area between two curves. So, say we've got two curves here, the function of x and g of x, so f of x and g of x. We want to find the area between them. Like we said before, like the area between the curves there is if we can split it up into these rectangles. Now, as you see, like we've got these rectangles as we've had before, and if you look at the height of these ones, it'd be the height of all these is the function value of x, the y value here, minus the y value of g of x. So that would be your height there, f of x minus g of x. The distance across, so the breadth of it, is all going to be the same. And we're going to call that delta x, so some change in the value of x. So what we want to do is we're going to add them all together. So and that's where we get this idea. So we get the area of the rectangle, the function of function of the x values, and doing the subtraction between them, times delta x, which is the base there. So we get and then when we add them all together, we're going from 1 through to some value n of the value that area, because that's the length times the breadth. So what we want to do is look at the idea again. So how do we get rid of all these areas here that are left over? So it's not very accurate with this amount of rectangles. But if we start to take smaller and smaller breadths of our rectangles, then it starts to become more accurate, because these rectangles start to fill more shapes. So the idea is that the delta of x is starting to be approaching 0. So the smaller it becomes, the more it starts to look like a line, just a line of those values. And the idea is that as delta x approaches 0, the limiting position of this statement here becomes the integral from a to b of the function of x minus g of x. So f of x minus g of x. So the top curve minus the bottom curve between the two values a and b. So that's a, and that would be b. So that's its upper bound, that's its lower bound, and we're finding the difference in the areas there and using the integral there. So and you can see it with this one. So the good thing about this one, unlike what we've done before where we have areas below the curve, it really doesn't matter if the curve's above or below the x-axis. So we're only looking at the area between. It will always give us a positive area. Because if we looked at that area there, if I took those functions and just added, so that looks like it's going through 4 there. If I added 4 to this function, basically it would end up on the x-axis, and 4 to each value on both of them would shift the whole curve up, for both curves up 4 units, and would put them both above the x-axis, and I'd still get the same area. The area between them is always going to be the same, no matter where they are on the number plane. So we don't really have to worry. What we really want to do is find 3 things: where the curves intersect, or what values are we given. So if we're given value of 4 here, so we find in that area. So find which is the upper curve in the region we're interested in. So which one's the upper curve, which one's the lower curve. Now if they crisscross over, that's when we have to start to play around with them a little bit. But generally there's one curve going to be above the other. And then we integrate the function of the upper curve minus the lower curve between the limits. And that's what we're looking at. We're looking at applying those values there. So let's have a look at a question in doing that. So we've got to draw x squared and the line y is equal to 2x. Find their points of intersection. So we've got x squared there, 2x is there. Now their points of intersection, we can solve them simultaneously and find that their points of intersection would be the origin, 0, 0, and 2. And the y value there would be 4. But we're really worried about the 2. So what we're looking at is finding the area under the line here and subtracting the area under x squared, because the red line here, the 2x, is above that one. So that's where we can see it there. You could really do all this in one. If you really wanted to say 0 to 2 of 2x minus x squared, that would work too. So we don't really have to worry about that. So integrate that function, because that's the top function. Integrate it, sub in the values from 0 to 2. Integrate this one, x cubed to 3, between 0 and 2, and we're doing a subtraction between them. But we integrate them just to get our values normally there. So x squared, sub in 2, sub in 0, and x squared becomes x cubed on 3, sub in 2, sub in 0, you get 4 minus 8 on 3, which is 1 1/3 units squared. So that gives us the area between those two curves. So you can do it that way, or you could do it all in one. So you could just say, take out that part and just say 2x minus x squared, and integrate that function that way.